Hey everyone, today's tutorial will be on adding or making our shaders compatible with Leadwerks lighting and also adding diffuse and normal maps to our shaders. So first, right now if you followed the first programming tutorial, we took out the directional light, but we'll want to add that back in because we're going to be using the Leadwerks lighting for directional lights. So just going to add that in. The other thing I'm going to do also is to tone down the ambient color a little bit, make it a little blue as well. This is sort of what we're aiming for by the end of the tutorial. In fact, I will make another box and or a sphere, and we're going to actually compare the result because this is sort of what we're aiming for. Okay, delete this one. So we want this to look like that. So let's start editing the shader. Okay, so this is sort of where we left off last time. You can take out all the lighting code because we won't be using that lighting right now. So how do we set up lighting for Leadwerks? Well, what we actually have to do is we have to set a few things. First thing we have to set is in our fragment shader, we actually need additional outputs. So frag 0 is for the diffuse output. We also have normal output, and so this is diffuse. We have a normal output, which is 1, and then we have a specular output, which is 2. So we're going to make frag data 1 all zeros, except the last number is going to be something kind of strange, which is 9 over 250. So basically a lot of flags are being thrown in here. There's a lot of material flags that are being added to create this number. Don't worry about that. For now, all you just need to worry about is adding this number in. Alright, so now we have, so now it doesn't look red anymore because it used to have a sort of a selection state. Like notice when I click, it'll turn red. We didn't really set it up for this mesh, but for this one, you notice that it's kind of red when you click. That was basically what was happening here, is that it was always red. Okay, so we're done with that. That's nice. And that's pretty much all you need to set up Leadwerks lighting. Okay, so we're going to actually get ready for diffuse textures. So how do we do these? How do we add textures? First of all, we have to open up the texture editor. I'm sorry, wrong one. Okay, we're going to open a texture. I'm going to be using concrete textures. Where are they? Concrete, diffuse, and .3. Okay, so we have the 3 textures going on. And if you look, you can actually kind of see some lighting that's being done on this. So we're going to go to fragment. Well, actually, sorry. We have to go to vertex. We actually have to add some new outputs. Well, let's start with the input first. So we're going to have vertex texture coordinates that are also being passed in by the engine. And we want to send these coordinates to the fragment shader. So we're going to be doing okay, so this is pretty simple. We just set this equal to this. Right, it's literally just a pass-through. We just set the output equal to the input. and we'll be able to access that from the fragment shader. Okay, so frag data 0. Alright, so the way we do textures here, they're going to be uniform because they're the same for the whole material. So anything that uses this material will share these textures. We will use, so you have to use this sampler 2D, meaning we're going to be sampling, this is actually a data type, we're sampling from a 2D object, which in this case is a texture. Texture 0. So texture 0 is by default the diffuse texture. If you look at the material, this is the texture 0, texture 1, texture 2, texture 3, texture 4. It starts numbering after you get to displacement. There's 7. I think it has support for 16 actually, but yeah, I don't think you'd need to use more than this. But if you did, I think there's support for 16, but I'm not 100% sure on that. So we have texture 0. So we're actually going to replace this diffuse output, and we will, instead, what we're going to be doing is, so to access, so first we need to get the coordinates. I'm sorry, I skipped a step. So our input will be vec2 ex text chord 0. Okay, let's make sure it should be a 2D vector. It's a 2D vector because if you open up the material, you see it as a 2D texture, right? So we just need the texture coordinate for left to right, or x, and up and down, or y. Although it's usually referred to as UV, but you'll see why I refer to it as X and Y in a second. So in our fragment shader, we get this passed in. That's good. We're going to have to sample this texture using these texture coordinates. How do I do that? Just simple texture command. And the first parameter is the texture name. The second is the texture coordinates. Okay, let's see, make sure it compiles. Yeah, sorry, I messed up on that. Okay, so let's make sure it compiles. Great, and look, it's textured with the concrete. Okay, now for the fun part, the normal map. This is going to be a difficult part. I'm just warning you right now. Especially if you're not familiar with normal maps, or if you don't have too much knowledge about linear algebra, this can be kind of difficult. But I will try to go through it as simply as possible. So we're going to have to take in a few more inputs, and I'll explain what they are. So our first input is tangent, vertex tangent, and the next one is vertex binormal. So what are these? We discussed earlier that the normal is when you have a vertex. I'll do it on this one because it's easier to see. It's basically what's coming out of the vertex. So it's basically what's coming out of the vertex. So here the normal would be going like this direction, for instance, because there's a vertex over here, and like orthogonal to it would be out here. In order to actually compute that, we would need the tangent, which is calculated along the texture coordinates from left to right. So it would be going from like in this direction. The binormal is perpendicular to that, so up and down. Okay, so these are just vectors. So again, like the normal and position, they're local vectors. We're going to have to change these into world space, and actually even camera space too. So we're gonna have to turn this into camera space. So in order to do this, we have to set up a inverse camera matrix. So this will be a new uniform mat 4 inverse camera matrix. Okay, and we're gonna actually make a mat 3. So this is a cool trick. Like you can do with vectors, you can actually do with matrices. This will take the top matrix 3x3 matrix in this 4x4 matrix. So we're gonna call this end mat. So we're actually gonna be multiplying this by times the mat 3 of the entity matrix that we had. So now we have this, and we're gonna multiply all of these by that, and we're also going to form output for each of these as well. So I'll just copy and paste all these, and we're gonna name it I'm kind of sticking with some of the Leadwerks naming conventions, so that if you look at the other shaders, you'll understand a little better. Okay, so we have these outputs. We're going to be doing something like, so binormal times nmat. Okay, and we're going to copy and paste this for all of the different ones. Basically all 3 vectors. So we have binormal, we have normal, and we have tangent. Okay, so does it compile? Yes, it does. Let's go back to our fragment shader. Sorry, this is the normal output. We're gonna use a normal map, which is the same naming convention. You have 1 for normal. Okay, well, we can actually borrow these texture coordinates for this too, because generally normal maps and diffuse maps share the same coordinates, which is why if you look at them, let me pull this one up, because this is easy to see. So that's the diffuse map. The normal map, it looks similar. I mean, obviously it's like purple or whatever, but like you can see the features sort of line up with each map, that's why you can borrow this. Okay, so we have the output here. Yeah, here's what we're going to do. We're going to specify a new vector 3, and we're going to call it normal. So what we're going to be doing, and we're going to change this to texture 1 to draw from the normal map. What we're going to be doing is, this is a local texture coordinate based on the normal map. We're going to have to multiply that by the actual, we're going to be using the world normal as well. And we're going to multiply the local by the world in order to get an accurate normal. So first of all, we need to make this, so with these normal maps, they're actually, the 3 color values represent different vectors. The red value represents the tangent strength, the green value represents the binormal strength, and the green value represents the normal strength. Okay, but they're all stored from 0 to 1 in a texture, because that's the only way you can store those values. So we're going to actually, but we want these values to range from -1 to 1, so they can point backwards, because a vector isn't constrained from 0 to 1. A normal vector would be constrained from -1 to 1. So we need to map that, and the way we do that is we multiply by 2 and then subtract 1, and now we actually have the real local normal. We're gonna have to multiply the vectors we got from this texture by the appropriate world normals. So we do, so like I said before, the x corresponds to the tangent vector. and I forgot to import them. Sorry. Forgot to set up the inputs. Okay, so we're going to do, alright, then we have to do the, like I said before, the normal, the y normal. So the y coordinate we get from this texture corresponds to the binormal strength. And then lastly, the z component of this texture lookup we did corresponds to the actual normal. Okay, so let me break this down to other lines so that it's clear. Okay, so we add all these vectors together based on the strength we got from this normal map. Okay, so now we have what should be the final normal. We don't need the alpha value. Alright, so let's look at what's happening here. So this deferred render, we're actually setting this fragment data, and we're setting it, and this is from the output of this fragment shader. We need to set this equal to, so this will actually be a texture that we're writing to, you can kind of think of. So what we need to do is we actually need to map this back to a texture. So like before, when I multiplied the texture coordinate by 2 and subtracted 1, we have to do the opposite operation. And that would be plus 0.5. Okay. So this would be mapping it back. Sorry, I made a mistake a little earlier on. This should actually be called the camera inverse matrix, not the inverse camera matrix. So make sure you replace that. It's over here on the top, and it's down here. Okay, so we should be able to, so once that's replaced, I was going to explain that this was the error that had caused that issue, but it wasn't. However, if you don't normalize it like that, you will get some weird shading sometimes. You see how it kind of changes color a little. This is due to that issue I was talking about. So make sure you map back to the texture form of these vectors. Okay, and so right now we actually have, it looks pretty decent. The normal map is kind of noticeable. Notice that there's actually something here. That's the spec value from behind, because we actually don't assign a spec value. Because if you actually look, you can kind of see the sphere behind it. So we actually have to assign a spec value to this, which we will do in here, in the fragment shader again. So what we will do is, the other issue I had too, I forgot to mention, was I had deleted this line. Don't delete that line, keep it in. I'm not sure why I deleted it. I think it was just an accident. So we're gonna have to set the spec value. It's just, so this is the spec value we set. So this will be equal to, I'm just gonna make it a vec4 right now. And we can just, actually I don't think that works. We can discuss specular maps later, but for now let's just make it really shiny. So you can kind of see that there's like this shininess to it, which kind of amplifies the normal maps a bit too, which I kind of like. Anyway, now you won't see the sphere behind it because there's actually specular data for this. Anyway, let me know what you think about this tutorial. Next tutorial will probably be on post-processing, at least the intro steps.